Lesson 8.5.3, Function or Not, Graphs of Functions and Non-Functions. In this lesson, we'll determine whether or not a graph represents a function and explain the reasoning. We'll also describe a context using function language, such as the output is a function of the input. Before we jump into the notes, I want to just revisit what a function is as we talk about inputs and outputs. So if I have an input where we're inputting a person or an individual, and the output is their birth month, each person only has one birth month. If I input Mrs. Tuitt and ask what is her birth month, out comes August. And there's only 1 month I was born in. If we input Mrs. Kingsbury and ask what her birth month was, only one thing comes out. And what we'll see in the lesson today is we're going to start talking about this as the output, the birth month, is a function of the individual, okay, or the person in our case. I wanted to do this because I want to make clear that it's important that the person is the input and the birth month is the output. I'm going to switch those around just so we can know how we can talk about how something is not a function. So in our first example, the person was the input. Now here's the same information, but this time the birth month is the input. And we've talked about this. If I have an input with more than one output, I don't have a function. So if my birth month is August and the output is a person with that birth month, it's Mrs. Tuitt. If I put August in again, I might get out a different person because there's lots of people that were born in that birth month. We'll throw Mrs. Kingsbury back in there just for giggles. February leads to Mrs. Kingsbury, but it could lead to lots of other people as well. Because there might be lots of outputs for an input of August, then I would say that an individual is not a function of the birth month. It's not a function. So I just wanted to look at that because we're going to be looking at that same kind of thing today, where we look at the same two variables, but where one of them is the input, and in another scenario where the other variable is the input. So sometimes it's a function and sometimes it's not. Let's move on to the notes. So we're on page 10. Let's start with our learning goals. First of all, we want to be able to explain why a graph does or does not represent a function. We have been focused on tables, but we'll look at graphs today. I think you'll like it. Explain why a graph does or does not represent a function. And the second one is to use precise language. Start talking like mathematicians. Use precise language to describe functions. And what you're going to hear me saying as I'm talking about this precise language is something is or is not a function of something else. This is going to be the output, whatever that is in the scenario, and we're going to finish with the input. So we'll come back to this language as we move through the lesson and talk about one thing being a function of another. So we have a scenario here where Ariana is running once around the track, and the graphs below show the relationship between her time and, so we have to jump over, and her distance from the starting point. Now, when I first looked at these graphs, I thought, what are they talking about? But as you're thinking about her distance from the starting point, I don't want you to think circular, or I don't want you to think as she's running around. Let me see if I can say this right. Imagine a track that somebody would be running on. As it's talking about her distance from the starting line, let's look at what that might be. So the distance from the start to this point is about, looks like 2 centimeters. And her distance from here to here, if I cut across the track, is also 2 centimeters. So there's 2 times when she's 2 centimeters away on my little example here, 2 centimeters away from the starting point. So I know you're probably thinking to yourself, no, 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 she went around the track. She's a lot more than 2 centimeters because you're counting all of this stuff in the track. But think about it as cutting from here directly to the point that she's at right now. So she's 2 centimeters away from the start. She's 3 centimeters away from the start here. And then she's back to 2 centimeters away from the start. So that's how we should picture this scenario. How far is she cutting across the track for any place that she's at as she's running around? Let me put this down here. That's what these graphs are representing. So in our first graph, it looks like the inputs are always x. Is the distance from the starting line. And the output is the time. So inputs are always x, outputs are always y. All right. And we know that if each input results in only one output, then we have a function. Let's see if that's the case here. We have an input, let's say, of 50. X is 50. Is there just one output for the time when she's a distance with 50 meters away from the starting line? Well, there's this point right here where it looks like it took about 10 seconds for her to get 50 meters away. And then she runs around the track, and there's a second time that she's 50 meters away. Up here, it looks like about 70. So there's 2 different times when her location is 50 meters from the starting line. And what that means is that this input has 2 different outputs. So this one's not a function. We'll write what that should look like in just a moment. But on this graph, you can see we've kind of switched what we're calling the input and the output. This time, distance is the output and time is the input. This time, this is my x and this is my y. I'm just going to write input again and output. The inputs are always the x's, the outputs are always the y's. Well, let's look at it again. So let's choose any time, 24 seconds. At 24 seconds, is there only one output? Yep, after 24 seconds, it looks like she's a little over 125 meters from the starting line. And at 26 seconds, she's just in one spot, and at 36 seconds, she's just in one spot. In fact, for every x value, it looks like there's only one place that it's going to run into this graph. So each input has exactly one output. So this one is a function and this one isn't. Let's use our language to describe what we're seeing here. And I'm going to come back up to our little statement here. If we have a function, then you might hear mathematicians say that the output is a function of this input. So we're just going to fill in the blanks here. The distance from the starting line is a function of the time in seconds. So we're going to start with the output. I'm going to write small. The distance from the starting line, that's the output, is a function of and then I'm going to say the input, the time in seconds. That was the output. This is the input. That's how it's done. Output first is a function of the input. So that's the language we use to describe functions. Let's do it again over here, but this time we're going to say is not a function of. We're still going to start by talking about the output. The time in seconds is not a function of the distance from the starting line. And again, that's because at this input, there's two outputs. So the time in seconds is not a function of the distance from the starting line. Running out of room. Okay, so that's the output. This is the input. That's how our statement's always going to go. Whatever you're calling the output is what you're going to put first. And that is or is not a function of whatever you're calling the input, your x values. So one more time, output comes first, and then input, and comes last. Whew. All right, now these graphs are still useful, but in case you missed it, Desmos doesn't mention it, but there's something called the vertical line test for whether something is a function. So if I take any vertical line and I pass it over this graph, and that vertical line that represents an x value, if that hits more than one point on the graph at the same time, then it's not a function. So I can tell this one's not a function. It's always hitting 2 points at once. But this one, if this represents an x value of 0, an x value of 6, an x value of 12, it's always just hitting my graph in one spot. That's a function. Let's finish up by just answering a few questions about these graphs. We're asked to estimate when Ariana was 100 meters from her starting point. All right, well, I'm going to come right here. Distance from the starting point was 100 meters. And it looks like there's 2 times that happens. We're just going to estimate here. So at 100 meters, that happens about halfway between 12 and 24. So let's say that's about 18 seconds. And then again at, we'll say 54 seconds. And secondly, estimate how far Ariana was from the starting line after 60 seconds. We could probably use either one of these graphs for it. We'd get the same thing. But this one's right above us. It's set up for seconds. So 60 seconds looks like about 75 meters. At 60 seconds, she's 75 meters away. And just for the record, if I went to this graph and I looked at 60 seconds, that's 75 meters as well. They're just flipped on their axes. So we'll finish up by explaining how we know whether or not something is a function. Is time a function of Ariana's distance from the starting point? Now we just said time is not a function, but let's explain why. Remember, time was the output here. It's not a function of her distance from the starting point. I'm just going to say distance. So we're referring to this graph right up here. Time is not a function of distance because each distance, each input has more than one output. Each input, that's distance, has 2 outputs. That's time. But with this graph, is the distance from the starting point a function of time? This time, Yeah, it is. We just said up here, the distance is a function of time because each input shows only one output. This time the input is time. Each second shows only one output. And here the output is the distance from the starting point. So we're seeing that same description of functions again and again and again. Each input can only have one output. If I have an input with more than one output, then it's not a function. If I have an input that can only have one output, then it is a function. So we should be able to look at a graph and tell right away if it's a function by looking to see if the x values hit two y values at once. And we should be able to use this language to describe functions, starting with the output being a function of the input. Good luck on your homework tonight.